Good morning, students.
Morning, sir.
Yeah, okay. So, can you start? Am I audible to every one of you?
Yes, sir.
So, in the last class, do you have any doubts regarding the last class? Do you have any doubts regarding the last class? I'm asking every one of you. Do you have any doubts regarding the last class? No doubts, I guess. Okay, so can you see this presentation? Can you see this presentation, every one of you? So, in the last class, we discussed regarding. So, in the last class, we discussed regarding. So, in the last class, we discussed regarding the different material properties. Yes. So, what are actually material properties? Now, look. Suppose there is. We discussed regarding the stress and strain, right? So we discussed regarding stress and strain. In stress and strain, what happens? In stress and strain, we all know that stress is force per unit area, and strain is what? Change in length per unit length. Now, the ratio of stress and strain is unity. The ratio of stress and strain is directly proportional to each other. Now, because of this, there is a constant which is known as Young's modulus, right? So now, due to this Young's modulus, what happens is that the materials are showing different properties. Okay, so the materials are showing different properties. That means what? Some of the properties that we can discuss here is number one, which is strength. Now, what is actually strength of the material? So now it is the resistance offered by material when subjected to external load. Suppose you are pulling some material, okay? You are pulling some material, and eventually what happens is that that material will I'm sorry, that material will what happen will resist being pulled or being distorted, right? So that property of the material is known as its strength. Yes or no? Now, yeah, can you all hear me? I'm getting no responses from you. I'm asking everyone, can you all hear
We
me?
can hear you.
And can you
Yes,
see
sir.
its presentation?
Yes.
Yes. So what is actually strength? Now, the strength is the what? Resistance that is being offered. Now, as I am discussing if you are pulling certain material, so what will happen? That material won't get pulled so easily, right? If that material don't get pulled so easily, then eventually what will happen? That material will that material will resist its deformation or distortness. This is known as what? Strength. Now, depending upon the type of load, the strength can be what? Tensile, compressive, shear, or torsional. Now you all know tensile and compressive. You all know. Shear we discussed in before class, in the last class. And regarding torsional also, I told you. Do you remember what is torsional? Students, do you remember what is torsional movement or what is torsional motion? Can anyone say what is torsional? Hello. Can anyone say what is torsion? Yes or no?
Rotation.
Yeah. That is how, what rotation? Can you say me? Ansari, right?
Sir, rotational force like torque, sir.
Okay. What happens in that case? What happens in that case? Any idea? I told you in the last class. That is why I'm asking you. I showed you some pictures and videos. Can anyone say what kind of rotation is happening in that case? No idea? Anyone? Any idea? Anyone? Any
No,
idea?
no, sir.
Pinpoint
The
name.
action of twisting.
Yeah, Nishita, what you say?
The action of twisting
The action of twisting. So what happens in that case?
of one end of an object relative to the other.
Okay. So you twist one end. So can you give a practical example of twist? Because these are important things actually. Can you give a practical example of a torsion or twist or any daily life
The
thing?
opening a bottle cap.
No, no, no. Opening of a bottle cap, how can it be torsion? Look, opening of a bottle cap, you open it, na? The one end, Nishita said, na? Like one end gets fixed, right? Yes or no?
What, sir?
She said that one end gets fixed, right? Yes or no?
Thing of
Sir.
क्या बोला? What you say? I didn't get you.
The action to which a craft departs from
Why are
being
saying things
planar.
so complicated? Aircraft and all. This is not torsion, na? That's a simple example I'm asking from you people. Now, if I show you, you will all laugh at it. Ah, just think, I'm giving you 1 minute, then I'll show you.
thing of
Ah, this is very interesting thing. I'm telling you. Do I need to show you? Look at this. What is this? You all do this thing every morning. Everyone does. You dry your towels, right? What happens? If you dry your clothes or towels, what happens? You just try to rotate it, right? You just try to rotate it with one hand in one direction and the other hand with other direction. You do it or not? Hello? Hello? Yeah, please be interactive. You do it or not?
Yes, sir.
Now, are you getting what is actually torsion? Now, are you getting what is actually torsion?
Yes, sir.
Yeah. So this is what. Look, you rotate it now. So that is basically the twisting moment or torsion. Clear? Now, don't forget. You don't forget, right? So that is actually known as torsion. Now, the maximum stress that a material can withstand, I explained you that thing also, ultimate strength. Ultimate strength is what? It is the maximum strength that a material can withstand, right? Suppose you are pulling it, the material, and there will be a time when the material will eventually what? When the material will eventually break down. That is known as ultimate strength. Now let us come to elasticity. You all know elasticity. I discussed. Elasticity means what? You pull a rubber band sort of thing. Now, if you pull it, it will come back to its original state. Right? That is known as elastic. The last class I explained someone why steel is more elastic than plastic. That's it. Then you go to stiffness or rigidity. Now stiffness means what? Suppose it is of an object. A stiffness is a property. Now what it means is it is the ability of the object to resist deflections. Okay, so it is the ability. Sorry, it is the ability of the object to resist deflections. Suppose a material is tried to be moved or deflected, then what will happen? It sometimes gets deflected, sometimes not. Now it is dependent upon the. Can you all hear me? What I'm saying?
Yes, sir.
Yeah.
Okay, okay, okay. Now it is that property of material to which it can resist deflections, and this is measured by Young's modulus. Now we go to the next one, that is plasticity. What is plasticity? Now plasticity is the property. There is elasticity and there is plasticity. Now for plasticity, what it is? That is the property of a material that allows its ability to undergo some amount of permanent deformation without failure. Hmm. That means what? In elastic material, it will come back to its original state, but in plastic, it will not come back to its original state. So this is known as the plasticity of a material. Then ductility is the property by virtue of which a material can be drawn into wires. That is known as ductility. Malleability and brittleness. Malleability means it can be drawn into sheets, like you put it into a hammer and it can be rolled into thin sheets. Okay. Now, for malleability, materials like copper, aluminium, these exhibits this property. Then comes what? Brittleness. That is the property for which a material can fail when subjected to elastic load. Like a material directly breaks down. So in that case, it is called to be a brittle material. Okay. Then the other two properties are what? The property of hardness and toughness. So these are the simple properties. Now this is a graph. This is a graph for rupture. So in this graph, you can see that under the curve it is modulus of toughness. That means how tough. Now there are other two properties. These are important actually. So number one is what? Resilience. Now it is the amount of energy that is absorbed by a material within elastic limit. This is termed as what? Resilience. So under resilience, what it is that within elastic limit, suppose the material will have to come back to its original state. I apply some force, it will expand. But in order to come back to its original state, it will release some energy. So that energy is known as what? Resilience. Okay. So after resilience, it is proof resilience. So it is the maximum amount of energy that a material can be absorbed within the elastic limit. Now resilience is the amount of energy that we can absorb, but there is a maximum amount. Like after before failure, suppose you are pulling a material or you are pulling a string. Now what happens? It will keep on elongating. That means what? It will absorb some energy. So eventually what will happen? At one time it will break down. At the point before breakdown, the amount of energy that is absorbed within elastic limit, now that is known as what? Proof resilience. And per unit volume, if you divide proof resilience divided by the volume of the material, then you get it what? Modulus of resilience. So these are the important terms. Okay. So any doubt in this part? I'm asking. So any doubt? Can you please ask me? Or I'll move into the next section.
You can move, sir.
I can move. You understood proof resilience, resilience, and all.
Yes, sir.
Okay, then let us move to the other part. The next unit. Before that, let us try solving a numerical. Okay, it will be more clear to it. Can you see the screen now?
No, sir.
Wait a minute. Give me a minute. Now can you see the string?
Yes,
Sir.
sir.
Yes. So try it out and give me the answers. You have to solve this numerical. Did you bring your copies and all? Try solving the numerical. Good. Look at this one. How did you find out the stress? Are you able to read the question? Are you understanding the question, students? Hello? Hello?
We are solving, sir.
Okay,
Wait, sir.
good, Tema, that's good. Very good. Others also please do. Okay, Suraj, stress is 1000 PA. Write the unit in Newton per meter. Okay, do not use pascals much. Newton per meter is much more standard. Okay, Suraj, Bora, just write it in Newton per meter. Okay. Okay, I'm getting answers from someone. Good, good. Stress. Hidam, write the units. Hidam, Bobby, just write the units. Okay. Without units, your numerical is incomplete. Please write the units. If given the answers, it's good. Okay, but then write the units. Good. Okay, 2 more minutes and I'll be sharing the answers with you. I'm giving 2 more minutes. Please try to finish it fast. This is a simple numerical. Okay, so now look at the answers. Now here, look, the diameter is given in mm. So we have to convert this thing into meter. I've received answers from only 1, 2, 3, 4, 5. Only 5 people has given me the answer. So what about others? Okay, let's see. Now, if you see here, the diameter is given in mm, right? The diameter is given in mm. Then we have to convert it into meter. Okay. Now the force is given in Newton. Remember one thing: the unit of stress is what? Newton per meter square, right? So you have to convert everything, right? So if you have to convert everything, then what happens? You have to convert this diameter thing, like it is given in mm, so you have to convert it into meter first. You got the radius here, so after that we'll be finding out the area. Huh? So area is coming out to be this one, 12.56 into 10 to the power 6 minus 6 meter square. Okay, so this is the area. So now what happens? Now if after area you have to find out what? Stress, strain and Young's modulus. What is the stress now? Stress is force per unit area. You know the force 200, right? You know the area. Huh? Area is how much? This one. This one is the area, right? That means what? This is the stress. We have to be specific with the units and the power up to which it has been done, or else someone has written only. I can see in the chat. Someone has written only 15.92 probosity. Your answers are correct, but if you have to put, you have to put it what? You have to put this. You have to convert it, huh? Not mm square. So if you write it in Newton per mm square, it won't be accurate. You have to convert it into meter, because the area is always in meter in stress. So Newton per meter square is the standard unit. So that means what? You have to convert it into meters. Okay. So then you have to find out the stress. Strain is correct for maximum of u. It's okay. Now Young's modulus. It is what? It is the ratio of stress by strain. As simple as that. Now here it comes out to be 1592 into 10 to the power 6 Newton per meter square. So you have to put the unit of Young's modulus. Okay, Young's modulus is wrong from maximum one of you. Just check it out. Just check it out. This one, how it is being done, right? Huh? The stress part is correct for maximum of you. Strain is also correct for maximum of you. But then Young's modulus, it is the ratio of stress by strain, right? So you have to simply what? You have to simply divide the stress by strain. Many of you have got wrong. Huh? So this is how it is being done. Is it clear now? Every one of you? Or do I need to explain it again?
Sir.
Do I need to explain it again? I'm asking everyone. Yeah, Suraj. Okay, you got it. Okay. So what about others? Do I need to explain? Only 5 people have answered the question. Rest should be interactive. So what about others? I haven't got any answer from anyone. At least you get it wrong doesn't matter, but you should have tried it at least. Huh? So do I need to explain it to anyone else? Okay, I guess everyone understood it. If you want to take a screenshot of this, you can take it. So now let us understand some basic definitions. Number one is what? Hello, can you see this?
Yes, sir.
Okay, so let us start the next unit now. Now, number one is what? The definition of a beam. What is actually a beam? As per this definition, a bar working under bending is termed as a beam. A beam is laterally transverse loaded member whose cross-sectional dimensions are small compared to its length. Now, in the last class, I showed you beams. Yeah. So now, what is actually a beam? So beam is a lateral member that is subjected to certain loads. Now, if you see in your home or in your structures, what happens is that if you see in your structures, what happens is that here, suppose I showed you this figure in the last class. So what happens? These are the horizontal members, right? These are the main support members. These are what? These are beams. In a building, these are called beams. Now, this support or this are basically transferring the loads. Now, suppose in the upper floors, what happens? In the upper floors, there is load is there. Now, this load has to be transmitted to the ground. So, how it is being transmitted? These are the beams. With the help of these beams, these loads are transmitted downward. So, this is now these vertical members are called as. You know what is this called as? Not pillar. Technically, these are called columns. COLOUMN. In pillar, it is layman's language. Now, in engineering terms, it is known as a column. And this is a what? Beam. The horizon. Remember, every time in a structure, if you look at your home also, the vertical members, what someone said to be a pillar, it is actually a column. And the horizontal members, okay, which I am showing you right now, this one, these are termed as what? Beams. So they are the main parts of a structure, and below this column there is what? Foundation. There is foundation or footing or whatever you call it. So this is how we define. Okay. So now what we do is, this is a laterally transverse loaded member. Their cross-sectional dimensions or the cross-sectional dimensions of the beam are very less when compared to its length. Since it is a horizontal member, so the length is very high and the cross-sectional dimensions are very low. So let us do one thing today. Is it clear for everyone today what I taught, the topics and the numerical obviously? Is it clear for everyone? Students, is it clear
Yes,
for
for
you?
me, sir.
Yeah, fine, good. These are not that difficult things, huh? So you can just